All right, let's get to work. So trigonometric substitution. Does it look okay on here now? For all these formulas, for these trig substitutions, a is greater than 0. So number 1, for integrals involving the square root of a squared minus u squared, let u equal a sine theta. Then square root of a squared minus u squared would be equal to a cosine theta, where theta is between pi over 2 or equal to and negative pi over 2. Number 2, for integrals involving square root of a squared plus u squared, let u equal a tangent theta, then the square root piece will be subbed by a squared, or the root of a squared plus u squared can be replaced with a secant theta, where negative pi over 2 is less than or equal to theta, basically in between negative pi over 2 to pi over 2. Biscuits. Forgot to draw my triangle. It's gonna bother me. Sorry, guys. I need to draw the triangle, then write number 2. That's okay. I already got it. Okay. Okay, so number 1, you need a triangle for reference. Otherwise, it's a little hard to see what they're talking about. So this is theta. This is the u. This is my a, the hypotenuse. And then you solve for this piece. Okay, so then we start number 2. Okay, now the triangle for number 2. This is U, this is A, and the hypotenuse is going to be A squared plus U squared. Now for integrals, involving square root of U squared minus A squared, let U equal A secant theta. Then square root of U squared minus A squared is equal to A tangent theta or negative A tangent theta, depending what U and A are. So for the positive version, that's for when U is greater than A. And theta would be between 0 and pi over 2, but not equal to pi over 2. This one is for when U is less than negative A. And theta would be between pi over 2, but not equal to the endpoints. Okay, so that's pretty much all we need for the examples. Draw the triangle before I forget. So for this one, it's going to be U squared minus A squared here, A and U. You guys get on this page? What's up, Hagen?
Okay.
Okay. Let me pick an easy one from the homework before I start these harder ones. Yeah, let's try this one. Hopefully it's not weird. 1 second. Let's write down here. Oh. Let's just not even doing it. Yeah, I'll just use the 1. Okay. So dx over x squared square root of 9 minus x squared. So we have to use a trig sub in order to do this. So if we look in here, which one does it look like? Number 1, 2, or 3? That's a 9, by the way. Yeah, it looks like 1, right? So yeah, we should rewrite the problem. Show some extra steps here. So that's the same as saying 3 squared minus x squared, right? So what is my a in this case?
Nine.
It's the 9 is the a squared, so the a is the 3. What is the u? Yeah, u is just the x, right? So I'm going to use rule number 1. U is equal to a sine theta. In other words, x is equal to 3 sine theta, right? Translating it to our own problem. What would be dx? What's the derivative of 3 sine? Yeah. Yeah, just 3 cosine, right? The theta. Okay. So we can replace dx and this inner part. We're going to replace the x right here. That's what we're going to do, and this x. Because x is equal to 3 sine, right? So dx will be replaced and the x will be replaced. The d theta, or dx is 3 cosine theta d theta. X is 3 sine theta squared. Go ahead and change it back to a 9, doesn't matter. Minus 3 sine theta squared. Are you guys still with me at this point?
Yes, sir.
Okay, let me know if there's any confusion. This will become 9 sine squared theta square root of, this will be 9 sine squared, right? So if I can just go ahead and factor this out right now. That cool? So this became 9 squared sine squared, pull out a 9, pull out a 9. Skipped a minor step there. Let me know if you don't see it.
How did you get that 1 inside the parentheses?
You factored this 9 out. So this is a 9, right? And this is a 9. So factor the 9 from both.
Okay.
You see it or no?
not right now. But
Let's show another step then. Oh, good.
I mean, I'm pretty sure it's basic algebra that I forgot probably. Obviously,
Right, so do you agree if we square this, you get 9 sine squared, right?
yeah.
Right here. So pull out that 9 in the next. So we factor the 9. You get 1 minus sine squared. Right?
See it.
So this will come out as a 3. But what is this? This is an identity. What is 1 minus sine squared? You guys remember?
17, 16. Okay.
Right, this will come out as a 3. But 1 minus sine squared is cosine squared, right? Agree? From the identities? So this 3 will cancel that 3. Okay, so then we end up with cosine theta d theta over 9 sine squared theta. And this is square root cancel the square, right? Then these cosines will cancel. Which will give us 1/9 integral of cosecant squared theta d theta. What is the integral of cosecant? Yeah, negative 1/9 cotangent plus c. But but we don't need we're not looking for cotangent, we're looking for x. So remember how when we did u sub, we have to go back to x, right? Same thing. So how do we go back is the question. So do you agree that according to this, x is equal to sine theta, then that means that sine is equal to x over 3.
Right.
Right?
Okay, see you tomorrow. Okay?
So change this into, use the triangle to take advantage of this. So I put theta here. Sine is opposite over hypotenuse. So opposite side hypotenuse. This will be 3 squared minus x squared, using your Pythagorean theorem or the formula that I gave you at the beginning. Look at number 1. Right? See how it's the same thing? Right, but we can kind of work our way through even without these formulas. We should know that sine is opposite over hypotenuse. No big deal. We can still create this. But what is cotangent using the triangle? Or tangent is opposite over adjacent, right? So flip it over. Yeah, so this would be negative 1/9 times adjacent over opposite. So there's the actual solution. So we got to resub back to x after we're done playing with the trig. So you see how when you do the trig sub, everything just canceled all nicely. Identities are there to back you up. Everything became more smooth compared to trying to figure this nonsense out. Like, it's not going to happen any other way. Sometimes there's other ways, but you can't find a good U sub where it doesn't exist. You have to do a trig sub. Any questions on number 1? Is that all right? Okay. You guys pull on that page? There's no rush here. Okay, so this one, number 2. So the homework's going to start out with just testing you to see, okay, which sub do I use? So you use the tangent one, or the sine, or secant. Once you get used to that, you just got to do the identities or see what happens. So u is equal to x in this case, right? What is a equal to? Yeah, it's going to be 1. Which rule should we use? 1, 2, or 3?
Three? No. 1, I believe.
Yeah, it's like
2.
2. Yeah. The tangent, right? So x will equal a tangent, which is just 1/10. Dx will equal, what's the derivative of tangent? You guys remember? Secant squared. There we go. Okay. That should be enough to build the triangle, right? We should just go ahead and do it now. We're going to need it eventually. So this implies tangent. Well, I don't have to do anything. It's already tangent. Tangent is equal to x, and tangent is opposite over adjacent, right? Which means that this is x squared plus 1 squared. So let's start doing our substitutions. So I replace dx with secant squared d theta. Replace x squared with tangent theta. The one squared isn't important, but I just want you to see that that's part of the formula, right? So, so what is tangent squared plus 1? Which identity is that? Yeah, this is secant squared. With secant squared raised to the 3/2 is going to cancel the half, right? So that will be secant squared theta d theta over secant cubed theta d theta. Oops, no, this will cancel, giving us 1 over or 1 d theta over secant, which is really what? With 1 over secant.
Cosine, right?
That's cosine. And we know the integral is cosine, right? It's the integral of cosine.
Sine.
Yeah. Tan theta plus c is our answer, but we don't need sine. So what is sine in terms of this triangle?
X.
Hypotenuse over what?
So opposites over hypotenuse, yeah. So there's the real solution, not the resub back. Pretty cool, right?
So we're gonna use the identities and
Yeah.
The current formula.
Yeah, you need to know your basic derivatives and integrals and your trig identities. And then these new rules for trig sub. I'll just put them on the sheet while you're doing these problems. If you don't have them memorized, just have them ready. Any questions on this one? All right, one more.
triangle, you said it says x squared plus 1 squared?
Yes. Yeah, we're just doing the Pythagorean. Well, thanks. Sir. All right, so this one at first doesn't look like trig stuff, but it is.
Okay.
Yeah. We need to
Right.
complete the square. You guys remember how to complete the square? Yeah, I had some special number right here, right? And then subtract that same number. That number is half of the b term squared. So half of 12 is 6, squared is 36. So I'm gonna add 36 and then subtract 36. To maintain balance, right? This will then is now a perfect square, so it'll factor as x minus 6 squared. 32 minus 6 is a negative 4, right? Now, this will be x minus 6 squared minus 4, which is really 2 squared.
Third.
So now it's in that form. Which technique should we use? Yeah, I think it's 3. Oh, well, the secant one, right? Number 3. Yeah. Okay. So our u is x minus 6, right? Our a is 2. So x minus 6 is equal to 2 secant theta, which means that x is equal to 2 secant theta plus 6. Dx would be, what's the derivative of 2 secant? Two secant tangent. That 6 is gone. D theta. Okay. Now to build the triangle, you solve for secant, which is equal to x minus 6 over 2, right? So the triangle will be, go ahead and do it now. Secant is 1 over cosine, right? So it would be hypotenuse over adjacent. So hypotenuse over adjacent. This will be right, or 2 squared if you want. Okay, let's replace everything now. So the top part will become 2 secant theta plus 6 dx over square root of, this will be replaced with secant. So secant, actually 2 secant. Got to replace dx. You guys read that? I have to kind of jam it in there. It's 2 secant theta tangent theta d theta. So this is all my side work here. You write it better over here. So right now it looks kind of disturbing so far. I see a 2 in common and another 2, so I can factor out a 4, right? So that'll give me secant theta plus 3 times secant theta tangent theta d theta. The bottom is going to be, so they have a 4 in common, right? 2 squared, 2 squared. So factor the 4, and this is technically secant squared theta minus 1. What is secant squared theta minus 1?
You factor on the 4 on the top.
Yeah. Does you factor this 2 out?
Okay,
And
so-
these both have a 2 in common. Yeah, let's get this up there. Trying to keep it more compact, but I don't think it's working for me. All right, so
Secant squared theta minus 1 is equal to tangent.
yeah, so this will become tangent squared, and the 4 and the tangent squared will cancel the root in just a moment. And the top part, I'm going to go ahead and multiply. That will become secant squared theta tangent theta plus 3 secant theta tangent theta d theta. Square root of 4 tangent squared theta. Cancel. Okay, so then we got secant squared theta tangent theta plus 3 secant theta tangent theta d theta over 2 tan theta. They both have a tan in common, don't they? That's good. This 2 will cancel with that 2, or that 4, leaving me a 2. These tangents will cancel with that tangent once you factor it out. So that'll really only leave us with this integral of secant squared theta plus 3 secant theta. You cool with that algebra step I skipped? Okay. Okay. Now what's the integral of secant squared? So that'll be 2 tan theta. Integral of this guy will be 6 ln of secant theta plus tangent theta. So you can use the integral table or you can derive this. Any questions up to this point? The integration is done. So now we have to replace all the trig stuff.
Is that,
Triangle stuff.
are those the symbol for absolute value?
Yes, it's absolute value. So let's replace it. Tangent is opposite over adjacent, right? So it'll be 2 times 1/2 times square root of x minus 6 squared minus 4 plus 6 ln secant. Secant and what? Hypotenuse over adjacent. So x minus 6 over 2 plus tangent, which is the same nonsense over here, square root x minus 6 squared minus 4 over 2. Of course, these cancel right here. It's not very pretty, but we got it done, right? Are there any steps that are weird? Okay. Yeah, because of the 2, 6. So yeah, integral of secant is the ln secant tan plus tan.
That's something I thought.
Yeah, I haven't memorized, but it's part of the common integrals. But you can derive it by doing I think it's an easy one. It would be some trig identities. Okay. That's pretty much it for 8.4. See if there's anything in the homework. Let me show everybody the homework really quick. See if it lets me. You guys see this? This is 8.4 homework. So it starts off with just asking, okay, what type of sub should you use? This is a tangent type, right? So A is 4, so you're going to use 410, right? This is a secant type. You can tell by the difference. So A is 5 squared, right? They're going to say a 5 secant. So it starts out with just testing, okay, do you know which one to pick? Then when you get to number 3, they tell you what the sub is. They just want you to do it. So 3, 4, 5, 6, they tell you how to do it. It's not till number 8, 9, and 10 that they get to the one that beat it, where they just say integrate and they don't tell you anything. So you need to figure out, okay, what is the sub going to be? Draw your triangle. And this one, just like the last one we did, or one of the last ones, with completing the square. All right, guys, you guys have any homework problems or anything? Yeah. Let's see where we are on the schedule. Forget. We're a little behind, I think.
When will the next test be?
Well, test 2, I think, is just ended or is about to end. You're talking about test 3, right?
Yeah.
Whenever we finish chapter 8. So I'm thinking next. It is Wednesday. So next week we're going to finish chapter 8 and review, and then start chapter 9. So yeah, I'm thinking I'll open test 3 sometime next week, maybe on Monday or next Wednesday. I'll open it up, and you guys can have till the end of October to take it. Okay, it'll just be just integration, and then we start my favorite chapter, chapter 9. All right, guys, so we'll stop here then. You guys all right? You all right on your homework? Amigos, I'll see you on Monday then.
All right, sir. Thank you. See ya.
See you later.
Bye-bye.
For the storms coming.